Hi, I am Dr. Sajid Khan, and I am currently working as an assistant professor in Grandition University, Sialkot. My area of expertise is information security, cryptography, Internet of Things, and multimedia security. And today, the topic of my presentation is security of Internet of Things with lightweight hybrid algorithms. Uh, I think Internet of Things is one of the most emerging terms, and it don't need any introduction. But still, I will have little introduction about this thing in my later slide. So let's start about my presentation. These are the contents of my presentations. Like first of all, it will be overview, then some attack surface area in the IoT, and some vulnerabilities in the existing security methods. Definitely, there are some security methods in the existing IoT devices also. So I will just put a light over the vulnerabilities in those ones. And the later one, I will just go through over the proposed research methodology and that I have proposed. And based on those proposed, I will just explain the working principles of different phases of my research. And at the end, definitely after implementation, each and every technique has some results. So I will go through the security analysis of the techniques that I have proposed. And at the end of this one, there will be summary or the conclusion of this presentation. First of all, the overview. I think so we all are well aware of these things, the encryption. And basically, we all knows like the data that is stored in the computers or in the storage devices is in the plain form. Plain form means it can be easily readable. Readable means if it's text data, then everyone can read that text. And if it's multimedia data or the image form or an audio form, anyone can listen, watch, or just see that things. So that is plain form. So basically, when we talk about encryption, then encryption means to convert that plain form into unreadable form. Unreadable form is if it's just a picture, we can just change into noise form, and if it's text, we can just change this text into some unreadable form. Unreadable form is into some symbols or some other things like that one, or into some we can just put that or we can just hide that text into some other cover images or some other forms. So encryption is basically efficient way and most widely is used to secure personal data, confidential data, and classified data. And before that one, in the from since from the beginning, there are a lot of techniques also that is used for the protection of data. I just want to have some like advanced encryption standard and data encryption standard, blowfish and crystal ciphers, somehow like that one. Those algorithms, like although those algorithms are decades earlier, but still those algorithms are being used nowadays, but at very limited levels or very low levels where the security is not needed. So those techniques are being used still, but those techniques was better for that era. And when we talk about the current era, then those techniques are not secure because of the computation power. Those techniques are no more useful for the current data protection. And at the same time, we talk about the internet security, the internet of things security, then we are well aware that there are a lot of devices, and with the passage of time, lot of more devices are just coming into markets and in our everyday lives. Like those devices are connected to internets, and from those devices, we are just collecting the data, and that data is being stored at some points in our homes, in industry, or in markets, or in some other way in the government centers or some other form. So at every place and in every area, those data are just being stored. And when we talk about those data is being stored, then it means there are a lot of more phases, a lot of more points from where attackers can just hack that data, can get access to that data. And if we just talk about the reports of Kaspersky, then it has just mentioned that in just 2021, the attacks, cyber attacks over the IoT devices get double from the previous year. And also from January to June in 2021, over some 1.5 billion breaches of Internet of Things devices took place. And it is just the Casper Sky reports, not just other platforms report. And this is huge increase in the cyber attacks. And this huge increase is just because of the IoT devices that are now in the markets. And with the passage of time, those devices are now connected to the Internet. And those attacks basically most of the time occurs because of some communication protocol or the vulnerabilities or the loophole in the communication protocol, because different devices are made by different vendors, different organizations for different purposes. So each device has different communication protocol or different security protocol or security implementation of different level. So when those devices just communicate with each other, then definitely hackers can get access through the loopholes to just breach our system or to get access to our data centers or to our data. So uh, for this purpose, definitely some other robust techniques, security techniques are needed. So I will in the later slide discuss about that one. But before that, the IoT attack surface area. IoT attack surface area means we all know like in IoT there are four major components like sensors, connectivity, data centers or data processing parts, and at the end user area. And the most like we can say like vulnerable areas are data centers. Data centers means the place where the data is being stored, and we all know like sensor is some of those devices that can collect data from surrounding environment or those data, and and that data is transferred to the central point through some connection, and that connection means connectivity somehow. Either it can be wireless connectivity or it can be a Bluetooth connectivity or infrared connectivity, and most probably, most often, it's most of the time it's a wireless connectivity. And those data from the sensor through that connectivity is passed to the data center where it's being processed, and based on those processing it's make some decision like whatever the algorithm or the tools you just apply over that one, it makes some decision, and based on those decision it just decide either to like informs or to make some notification to the user side in the user interface or not. Like it can be triggering the alarm if it's temperature sensors, and then if it's some intrusion detection data and intrusion about the intrusion detection decision, then it can make so like triggering the alarms or creating the live videos or making the live video of that intrusion in somehow like this one. This basically this is just a general overview about this major component. So most of the time the attacks in the IoT devices occur over the devices, but at the same time storage center also are vulnerable to attacks, and communication channel like through the communication channel, either wireless or the LAN or some other way, the people can get access to our LAN. If it's LAN, then they can just pass some things over the LAN cables and they just read or whatever we are just transferring. They can also just monitor that thing, and also at this other side, application and software side also. So, and the most vulnerables are the most crucial are the devices and the storage center, because storage center is carry the lot of data, and those data is much more important for everyone, for the privacy purpose, for the security purpose, and for other purpose also. So those storage centers are the most targeted places for the hackers or for the attackers. Vulnerabilities in the existing. Definitely, there are a lot of devices, IoT devices, which came with some security protocols or security application built in. By default, whatever the security is implemented in that one, but still that security is not enough. That security is not enough means because different devices are made by different vendor, and when different vendors make different devices, then it means each device or each vendor has its own protocol, and each device has its own communication protocol or the data transfer protocol. And when different devices they just communicate with each other in the central point or in an IoT network, then there is some loophole. That loopholes create a positive or the waypoints for the hackers or the for attackers to get access to our system. So in the existing devices, it's not possible to implement the security properly because of those devices are limited in powers and limited in battery powers, and also at the same time, those devices just their first priority is the communication, not the security. So security is somehow at the second stage, and that needs to be implemented. When we talk about the vulnerabilities, then most of the communications or most of the data just either it's encrypted form, it gets cryptanalysis, it get accessed, or it get we can say like stolen through known and chosen plain text attacks, chosen ciphertext attacks, or differential attacks. These are some attacks types that are currently or nowadays are very famous and can easily be implemented over different data. At the same time, when we talk about the security of devices, then majority cases devices came with the security that is very limited. Limited means the security is not enough, the not robust, and that can easily be break or broken with the brute force attack. And brute force attack don't need any introduction because it means just trying to crack the password with multiple attempts, with the multiple combinations, like trying to just open the system or trying to get access to your system with all possible combination of the password. So I have just told you about these things in the previous, in the Internet of Things, there are different components, and it's not possible to implement the algorithm or the security over sensor side because sensors are very limited in powers, and if we apply any robust algorithm over there, it will consume battery and it will lead to a shorter lifetime of that sensor. That's why most of the cases the security is implemented at the central point or the storage point, because storage point is the one of the most crucial parts and that contains a lot of data that collected from all the sensor. So in my case also, I have implemented the security over the central or data center point where I have applied a hybrid techniques. What is hybrid technique? I will discuss in the later side. Like hybrid techniques mean and two different techniques means the first techniques that we know, like if one form, then the other techniques will be applied after changing the data into some other form. And what that means I will explain in the later slide, but the first one, like we all knows, like all the data in the computer is stored in the binary form. Binary form means 101010 form, no matter it's audio data, video data, or text data, whatever it says, or image data. So it's stored in the computer in the binary form, and we all know like this is a huge amount of data. So what I have implemented is if just go through some short history, there was a Fistel cipher that was very famous cipher, basically named after the Fister. So I have just applied made some changes or made some amendment in the structure of crystal cipher to make it more efficient. So because of that thing, I have named it crystal structure bit inversion. So whatever the data you have, either it's huge amount or it's the bulk form, the data will be divided into two different forms. Like if you have a full amount of data in 1 KB or 500 KB, then it will be divided into two half forms, like 250 KB and 250 KB. It will be equal to 500 KB. So whatever the data is divided into two equal blocks, that will be left bit column blocks and right bit column blocks. I have just named for the uh, some ease purpose. So the basically the purpose of this division was, for the left column blocks, the bit change will be from left to right, and for the right column block, the bit change will be from right to left. This is basically just the bit inversion. Bit inversion means the value of each bit will be inverted. And inverted means like whatever the bit the value will be, it will be get into opposite form, and because of those opposite form there will be a change in the value, and change in the value means like for if it's the least significant bit or the most significant bit, based on those one most significant bits means the change in the value will be plus 128 or minus 128, and for the least significant bit means the change in the value will be plus 1 or the negative 1. And plus 128 means like if it's a 0 and it will change into 1, its value will get increased to 128. And if already 1 and the algorithm will change into 0, its value will be decreased 1 minus 128. Because of this one, I have just termed or highlighted this one into plus minus 128 or plus minus 64 like this one. So this was the unique structure that I have made. Basically, this is very fast structure, and because of its fast structure, the implementation, very easy implementation, I have just named it lightweight. And the second one, that was the DNA rules. We are, I think, most of us familiar with one. Like only there are 8 DNA rules that follow the Watson-Crick's principle. Watson-Crick's principles means the complementary rules. These 8 rules, DNA rules, follow the Watson-Crick's principle rule. And because of this 8 rules, we can just implement these things in our text data or in our security also. So how I have implemented here, we are you can see from here like it's 8 DNA rule, and for these 8 DNA rule, I have made this mathematical model, and this is also a unique model I have just created by myself. And you can see from here these are 1, 2, 3, 4, 8. These are 8. Basically, these 8 depicts 8 DNA rules, and these 8 DNA rules are just for the purpose of 8 different models for 8 different rules. So by the values through the value, and over this one you can just see there is some values highlighted with the arrows like 01001110. These are basically the values, and we all know that, as I have just told you before, that there is a huge amount of data, and that huge amount of data is just transferred into matrix form. And we convert that huge amount of data 1010 data into matrix form, that matrix is subdivided into shorter matrix or submatrix, and that submatrix, because of those submatrix, I just based on the first value and the last value in every submatrix. Like if a short matrix is a 16 cross 16 matrix, so we will divide into 4 cross 4 matrix into multiple matrices. These multiple matrix, 4 cross 4 matrix, for the first value and the last value of this matrix, based on those value, these dual DNA rule allocation will be implemented. And these dual for this DNA rule allocation, for the first rule which need to be implemented is mentioned here, NP1 and NP2. And for the onward, for the second to onward, that will be n minus 1 ith into n minus 1 jth. And here ith and jth are basically two particular bits that we have just reserved for the rule allocation method. And mod B, basically it's 8. And based on, because there are 8 rules, so that's why B, the value of B is 8. So based on this thing, I have just made some security analysis after implementation of my lightweight security algorithm. And after implementation, I have just got some entropy values. Entropy values, I think entropy values don't need any explanation. Entropy means the haphazardness or randomness. The more the entropy value, the better is the security. And the ideal entropy value is 8. And whatever the like ideal interval near to ideal values mean the better security. And we can see from here plain values of the text, a plain value of the multimedia data was 4.338, and for the encrypted value it was 7.99. Basically this value is for the image, for one of the image. So you can see from here the plain value and the encrypted value. Encrypted value is very near to the ideal value. It means like the security is much better in this one. And the second one is the histogram. You can see from the histogram, like if the histogram is not smooth, then it means anyone can make the frequency of occurrence attacks possible. And if the histogram is equal or smooth, then frequency of occurrence attack is not possible. And histogram also shows like the encrypted data histogram is smooth, which makes it possible, or which makes his depiction like which is depicted that the security of our algorithm is better. At the same time, the time complexity, all knows like each algorithms have different time complexity or different running time. So less the time complexity, the better is the algorithm. So this chart basically depicts like below x-axis is the resolution and y-axis is the time. And you can see from here for the lower resolution images or lower resolution multimedia data, the encryption time is very short. And for the higher resolution like 1920 into 1200 resolution, the encryption time is high. And definitely, it's a obvious thing. Like the higher the resolution, the more it will takes more time, and this shows the time complexity of our algorithm. So at the end, I just want to say like although there is no algorithm that is 100% secure, and what we can do is just to make any storage device or anything to secure at the maximum extent. So earlier techniques, that was the unique techniques like advanced encryption standard or data encryption standard, those were the sole techniques, and those are not implementable for the current era. So hybrid techniques are much more better for the current era. These are more robust or more better for the security purpose, and it's hard to crack these hybrid techniques. Secondly, I just want to say like the novel methods, novel mathematical models, like if it's lightweight and easy to implement, it will make the efficiency of the algorithm much better in in the comparison or of other algorithm which takes more time. Because if it's lightweight, definitely it will take less time and the computation power will need less. At the same time, if the algorithm if the techniques is providing better results or enhanced results, we can say it's better in comparison to the other. And at the end, I just want to say like the hybrid techniques are very much effective for the current era. And the proposed hybrid technique that I have just put highlighted, I have introduced in this presentation is much more effective, and it has potential to apply for the multimedia communication, for the storage area, and even at IoT devices edge points. So after implementation of this hybrid techniques, we can just make our IoT devices or IoT networks much more secure as compared to before. And because of that security, the privacy or the data of our personal data, no matter or private data or confidential data, no matter what type of data is, it can be more secure as compared to before. And I think that was enough for the today. And thank you so much. These are some references of my presentation. And thank you so much. If you have any time, you can just contact with me through my email address. Thank you so much.